Okay, so before we create a table, we're going to drop a table just to make sure that everything works well. On the opposite of that, with a view, we're going to do create or replace view. And we do that, create takes care of us if that view doesn't exist. Replace replaces any existing view by that name with the new select query that you add to it. So had we done it, or you should be able to run this create or replace view in your code, and it'll actually replace that table that exists out there. We won't do it. It works as advertised. You can go through and test it if you desire a little bit later. Now, we need to talk about how we get data into Oracle. There are programs out there, in fact, SQL Developer is one of them, that if you bring up the data, you can actually go in and edit it. Bad, 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 no, 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 go sit in a corner. Because once you start to go into your actual data display and edit the data, how do you know that you're editing the right entity instance of the data that you have displayed up there on the grid? Yes. Another thing you'll see, the tables and views we're working with right now work with a minimum amount of data. I think the most entity instances we have in any one table is 20 or 24. If you start to look at 1,000,000 records, you're going to find out that that data grid that's displayed at the bottom of SQL Developer takes quite a while to update. And you may think it's all the way updated and start to edit data in what you think is a correct instance, and then all of a sudden the tables are going to update, and you're not going to know what happens. So for that reason, we use an insert statement to insert data into our tables. Now, you can see the insert statement from page 152 up on the screen. It's very, very simple. Insert into whatever the table name is, values, and then we list the values. Now, a couple things about this statement. You can put all of that information on one line if you want to. My technique is where I'm putting the data, I'm going to put that on a separate line. The reason for that then is if I create a macro out of Excel to enter data for me to create insert statements, I always know that on the second line is where my data is going to go in. So that's just a little option that I use. Notice down in the code that starts at line 6 that we can add information into a table and not have to enter all of the attributes. So what we're seeing here, and this is one I try and divide out into 3 lines if I can. Line number 6, insert into whatever the table name is. In this case, 0409 Foods. Now, the next line, we are listing the attributes that we're going to update, or we're going to insert, if you will. Product code, description, supplier ID, and price. Those are not all of the attributes that describe that table. So we have to list them. And we list them in the order that they occur in the table. Then the third line are the values that we are going to insert into those attributes. So the product code is BP, the description is blueberry pie, the supplier is AAR, and the price is $1.60. So we can either insert data into all of the attributes in a table, or we can only insert, or we can insert data into selected attributes in the table. It works extremely well, but you have to remember to click the commit button up here that's circled in red. If you don't click that commit button, you can run all your insert statements, you can see the data in the table, and when you shut the database down, all that data goes away. So you have to commit the data that you insert. Yeah, I shook my head too when I learned it, Faith.
That's so
not
scary.
fun. It is very scary, yeah, but it makes you think.
Do you have to commit it for each time you do it, or right
No,
before you
ma'am.
close it out?
Right before you close it out, the question was, I keep forgetting, poor Linda's listening to us and can't hear your questions. And in this case, James too. The question was, do you have to commit after each insert statement, or can you commit at the very end? After all your insert statements have run, you can do a commit and you're safe. Okay, you don't have to do one after each insert statement. Think about trying to load 1 million records and having to do a commit at the end of each record. You'd be here until next fall semester.
I definitely do more than one commit while I was going through them, though.
Yeah, you might want to do that. You noticed in the spool folder that I showed you, I broke my records up into million increments.
Because otherwise, one little power surge, you just lost it all.
Oh, yeah.
Am I getting ahead if I ask about the commit command?
No, go ahead and ask.
At the end of running all this, can't we just type commit semicolon and it'll lock it all down?
Absolutely.
You wanna,
There is also a command that you can type in, a reserved word commit. And if you would go through and find the end of each of my statements and look at it, you'll notice that commit is in there. In fact, I think I have commit in every 10,000 records, I believe. So there are ways to get around it. Right now, with the database, again, that we're dealing with, we have very, very few entity instances in all of our tables. So we can hit commit at the end of them. But you're absolutely correct, Lee. There is a reserved word commit. And so what this is showing us is down on line 12, we've entered the data, and there it is right there in our table, and we've committed it. Now, again, the gotcha is if you hadn't committed it, you'd still see the data there. But once you break that connection to that database, that data will go away. And this is probably, with new Oracle programmers, the biggest gotcha that's out there. They'll enter data and forget to commit it. Now, we can write out what we want to insert into a specific table using an insert command, but we can also use that insert command and run a query to pull certain pieces of data out of a different table and populate an even different table. And that's done in the example on page 155. You can see the code here. You're going to insert into a specific table our select query. And again, my recommendation is you've got a select query, run it first, make sure you're getting the data that you want before you put in line 2, which is the insert into table. Same thing here. If you don't put commit down, or you don't press the commit icon, you can load all that data, but it's going to go away once you break the connection to the database. So again, chapter 4 is the gotcha chapter on some of the stuff that we're picking up. And this is an example of what happens. We pulled that data out of the original database, and we've created a new table. I'm sorry, we have populated a different table with that data. Notice we've committed the information for the blueberry pie that we inserted, so that data is there. Would it be there if we hadn't committed?
No.
Think. Well, I'll accept no if you qualify it, Lee.
I'm gonna qualify it with, this is what we call RAM.
Yep,
It's volatile.
it's volatile. Exactly. So if you hadn't done commit, it might still show up, but as soon as you break that data connection, it's gone. We can also do an update to our tables. And that's a recommended way to go through. In this case, we're going to change the price. And notice how we're doing this. We have an update. We tell Oracle the table we want to use, and then we can actually write a formula. I'm going to set the price as the current price plus 10 cents. So Oracle will actually go in and do the math for us. So it becomes very easy if you're printing out a menu, or if you have 1,000 stock items at a grocery store that you want to increase the price by X number of cents. You can write a quick update query and it will do that for you. Yes, sir. Back to our slide.
Update statement to correct a misspelling?
You could do an update statement that just updated that one. The question was, if you had a misspelling, could you do an update statement to correct the misspelling? Yes, you could.
Would that be the safest way to deal with that? Since you can't,
Probably.
since you can't correct it in the query itself. Or you said you can, but you don't want to.
Well, the way it's normally done in most of the database groups that I've been in where they're actually doing data entry. Understand, a lot of data entry is done from machine to machine, or RFI chip, radio frequency chips, into a data collector. The last time I worked anywhere where they did actual data entry, they did a double entry system where you type in the data once, the machine stops for X number of seconds, and then you type that same data in again. If the data matches, then you're allowed to go on to the next entry.
Well, for example, it's not a misspelling. The lady got married, so you need to correct her last name.
Then you do an update statement just on that field. Yeah,
But you
or
don't
that
do it
attribute.
inside the view itself.
No, view's just a
No,
pretty record.
okay, the question was,
Yeah, it's letting me click in there, which is kind of why I'm asking.
hang on a second. Okay, remember I said that a view allows you access to that data. So you could go into a view that you've run, look at the data on the data grid, and go ahead and change that value. And then you would have to hit the commit statement. So yes, you could do it through a view. However, that's not the way most companies want you to update it. They would rather you run another update query to change a lady's name when she got married.
Is that going to update the real table?
Yes.
That's what the update does.
The
Update
question-
table, not the view.
Okay, the question was, it updates the table, not the view. I need to pose a question to you. What is a view? Is it data? No. It is a query.
Right.
And a query that displays selected attributes from a table.
So if you change it in the query, you didn't correct the table. Just because you corrected it in the view doesn't mean it's going to pass up and fix the table.
Now, the only data that Oracle stores is data in a table. There is no data in a view. Now, what the view is showing you is the data out of a table. And if you go into the design grid and you correct what's displayed, you're not correcting the view, you are correcting the data that's in the table. Okay? I think I maybe didn't make that clear earlier in the lecture. The only thing in Oracle that contains data is a table.
Okay, got that point. When you run that query,
So here is the example of the Oracle script that actually creates our L_bar employees table. The only line of code that you don't see is the drop statement that occurs just before the comment, create the table. Okay? And we look at how we create each attribute. So the reserved words are create table, and then we give it a name. Now, this is done in all uppercase. You can do it in upper, lowercase. You can do it in camel case. Oracle understands just about everything. But in this example, I went all uppercase for some reason. Where people make errors, if you'll notice, and you can put all this on one line too. I highly recommend you don't, but you can. My preference, create table and whatever the table name is. And then I'm going to hit the enter key and I'm going to put my first parentheses. People forget that one. So if you run into an error as you create tables in the lab exercise Friday night, that's the first thing you want to look at. Then we're going to identify the attribute. Immediately after it, you can use just one space and then type in what type of attribute it is. My preference, I like to tab over one or two tabs so I can line up all of my attribute definitions so I can check them out. We'll get into this a little bit more in chapter 5, I believe. But basically, we have 5 different things that we create in our database, or generally create in this class. First is a number. And notice our number for employee ID is a whole number. It's an integer. And the parentheses after number indicates that the largest number is going to be 999. Okay, so we're going out to 999. The next attribute we create is first name. And here we're using a varchar2, a variable character 2. And we're saying that that first name will contain no more than 10 characters. Now, the reason I like to use a varchar2 is that if I only use 5 characters to create an instance first name, then that's all the memory that Oracle will reserve for that instance of first name. If I use a char, C-H-A-R, and I say I'm going to reserve 10 characters, then it will reserve 10 characters, whether my first name is just one initial or my first name is 10 characters long. All right. So if you have a large database, it's prudent to use varchars all the way through. You can also see we've done the same with last name and department code. They're all varchar2s, and they have different values for the size that they're going to be. Now we come down to the hire date. And in Oracle, we only have to worry about one thing. We just put the value date in there. And it will allow us to record a date, and it will store a date in a specific format. When we get into Chapter 5, we'll touch on that. Let me give you a footnote here. If you want to record the system date, you can actually access that, and every time you have an entity instance for a new employee, it will take that hire date as whatever the current day, month, year, hour, minute, second, tenths of a second are, and record that for you automatically. It's a good way to do it because it eliminates errors. Okay? However, if you've got data entry that occurs after someone's hired, then you probably wouldn't want to do that. So you have to know how your database is being used. Credit limit, we're talking about a dollar value here, and notice how that's written. We see the size of the number, then a comma, and then we're told that 2 places in that number are to the right of the decimal point. So in this instance, the value of our credit limit could go up to $99.99. Okay? Phone number, again, a VARCHAR, and then manager ID is a number. There's a rule of thumb in Oracle that says if you're not going to perform addition, subtraction, multiplication, or division on a value, it should be a character, some form of a character string. Now, when we get into the big databases, you'll find out they violate that, but they do that for a reason. And we'll talk about that in advanced databases next 8 weeks. So we're not going to do anything with the phone number. We'll put the phone number in as a VARCHAR, and it's an office number, and this indicates that it's a 4-digit extension, and we don't need any more than that. So we'll put that in. Now, we're also talking about alter table, which will come up later, adding constraints, and adding a primary key. And we're going to get into that in Chapter 6, I believe. So think about those, but don't worry about them right now. Then you look at our insert statements. Now, flashpoint quiz. You see that insert statement, insert into L_bar employees, values, and then you see the values. What's that tell you?
You're gonna put null for any columns you don't have anything for the word null.
Partially correct. What else does it tell you?
You need to input it in the order in which it's listed.
Correct. And one more thing I told you.
While you're entering a primary key there, 201, 202, can't that be auto increment?
Well, that could be auto-incremented, but we haven't got to that yet. Our primary key is, if you look at the constraint, our L_bar our employee ID. Now, what we're looking at is, since we see the word values and then the next thing we see is a parenthesis in our data, that means that we have data for every attribute that's in that table. So as we run that, I misunderstood what you said then, Becky, sorry.
I probably didn't word it right. But that's what I
Okay.
was trying to say.
As we run this, we know that the data is going to go into every attribute, and Becky, you were absolutely correct. When we come to an attribute we don't have data for, we're going to load it with a null value. Remember again, null is the absence of any data. Okay? Questions?
How much can you get paid doing that?
Depends on how big a headache and ulcer you want.